Dear students, today we are going to discuss the remaining part of design process and determination of equivalent single axle load. We have already discussed this particular slide uh, and you can see here the typical assumptions which are used in the analysis of the pavement are mentioned over here. On the next slide you can see the estimating accumulated wheel load repetitions. The traffic characteristics are determined in terms of the number of repetitions of an 18,000 pound single axle load applied to the pavement on two sets of dual tires. If you just recall the definition of the standard axle, a single axle with dual wheels carrying a load of 80 kN or 18,000 pound is defined as standard axle. On this particular slide you can see the load equivalency factors corresponding to different axle loads, and here this column is meant for the single axle, this is meant for the tandem axle, and this is for the tridem axle. So you will have to use this table if you are knowing the axle loads. How to estimate the traffic mix if field data are not available? In this case, axle load data must be available, so we can use this table and you can consider these types of traffic, or you can say these types of vehicles. For example, when you are considering the interstate rural highway, so you may take 2 axle 4 tire as 43% of the total traffic, and 2 axle 6 tire 8, and so on. So you can see that if you just add all these numbers, the sum is equal to 100. The same concept can be used for the other types of the roads. Well, there is one correction needed here. If you just look at that, here you must take it like that, less than 1 or equal to 1. For this particular case, that is the 6 axle or more. How to estimate equivalent single axle load if axle loads are not known? In that particular case, truck factor is to be used, and you know the truck factor is defined as the number of 18,000 pound single load applications caused by a single passage of a vehicle, and you can see the formula for the truck factor over here. Well, on this particular slide you can see the distribution of truck factors for different classes of highways and vehicles, and let's say if you are considering the interstate highways, in that case we can pick these truck factors corresponding to these different vehicles. Determining the accumulated equivalent single axle load, uh, you must be knowing the design period, traffic growth rate, and the design lane factor. Usually a 20-year design period is used. Traffic growth rates can be obtained from the planning division of the State Department of Transportation. So here you can see the table, and with the help of this table you can determine the growth factor G sub JT, and you can also use this formula to determine the growth factor. As far as the design lane factor is concerned, you can use this table and you can see that the number of traffic lanes in two directions, if there are 2 lanes in the both 2 directions, then 50%. If there are 4 lanes, then 35 to 48%, and generally we take 45% for this case. In the case of 6 or more lanes, in that case 25 to 48%, this is the typical range, and generally we take 40%. So design lane factor, the pavement design is done for the highest loading case design lane. Typically the outer lane is subject to the highest loading. Now look at this particular slide. Determining accumulated equivalent single axle load when axle loads are used. In that particular case, this formula is to be used to determine the equivalent accumulated 18,000 pound single axle load for the axle category I. So here you can see different parameters. F sub D, that is the design lane factor. Capital GJT, that is the growth factor for a given growth rate J and design period T. AADT, this is the average annual daily traffic for the axle category I. And N sub I, that is the number of axles on each vehicle in axle category I. And F sub EI, that is the load equivalency factor for axle category I. Well, there is one important note is given, that is the AADT used here is the total for both directions. So keep this thing in the mind. Well, if you just look at the average annual daily traffic, you can say average number of vehicles per day passing on a section of a road during particular year in both directions. That is called as the annual average daily traffic, AADT. So this formula is to be used when axle loads are being used. On this particular slide, you can see another formula. This formula will be used when the truck factors are being used. So determining accumulated equivalent single axle load when truck factors are to be used. So this formula will be used, and in this formula again you can see F sub D, that is the design lane factor, G sub JT, that is the growth factor for a given growth rate J and design period T, AADT, that is the first year annual average daily traffic for truck category I, and F sub I, that is the truck factor for the vehicles in truck category I. So when you are having the equivalent single axle load ESAL for different vehicles or different trucks, then the accumulated equivalent single axle loads for all categories of axle loads can be determined by using this formula. So in this formula is applicable to the both formulas of the ESAL that we have just discussed. This table is showing the equivalent axle load factors for different axle loads, and then there are three columns. This column is for single axle case, this is the tandem axle, and this is for tridem axle. The same sequence you can see here. And this is the complete table to get the growth factor. So design period in years, and when there is no annual growth, then this column will be consulted. Otherwise, here you can see the 2% growth is there, so in that case this column will be used to get the growth factor. This is meant for 4% annual growth, and so this column will be used, and Similarly, you are having 5, 6, 7, 8 or 10% annual growth rate. This table will give you the growth factor. Growth factor can also be determined by using the formula of the growth factor that we have already discussed. Now we are going to solve two problems. In this problem, if you just look at that, we are going to compute accumulated equivalent single axle load for a proposed 4-lane highway using load equivalency factor. So look at the statement. A 4-lane divided interstate highway is to be constructed on a new alignment. Traffic volume forecast indicates that the average annual daily traffic (AADT) in both directions during the first year of operation will be 12,000. With the following vehicle makes and axle loads. So look at that. Passenger cars, in that case 1000 pound per axle load is there, and passenger cars are comprised of 50% of traffic. 2XL single unit trucks, in that case 5000 pound per axle load is there, and this particular type of vehicles are comprised of 33% of the total traffic. 3XL single unit trucks, that is comprised of 17% of the traffic, and in that case 7000 pound per axle load is there. So if you just add all these percentages, the sum is equal to 100%. The vehicle mix is expected to remain the same throughout the design life of the pavement. If the expected annual traffic growth rate is 4% for all vehicles, determine the design equivalent single axle load. So as you can see here, the axle loads are known to us, so we are going to use this particular formula, and we have already discussed this formula. So this formula is to be used when the axle loads are known. From table 20.6, the growth factor is 29.78 in this case. From the table 20.7, there are 4 lanes, so F sub D is 45%, but it will be taken as 0.45 in the formula to determine the equivalent single axle load. From the table 20.3, we can get the equivalency factor, the load equivalency factor for passenger car, 2XL single unit vehicle, 3XL single unit, and you can see that these are the load equivalency factor corresponding to 1000 pound axle load, 5000 pound, and 7000 pound. So it means by considering these axle loads, we have got the load equivalency factor from the table 20.3. Now it's time to use the formula, this one. Now this formula will be used one by one for the different categories of the vehicle. First, look at the passenger car. Now here you can see 0.45, that is F sub D, 29.78, that is the growth factor, and the average annual daily traffic for that particular vehicle, passenger car, 12,000 multiplied by 0.5. Why is it so? Because 12,000 is the annual average daily traffic, which is given in the question statement, and it is being multiplied by 0.5 because the passenger cars are comprised of 50% of the traffic mix. Then 365, as in the passenger car we are having the 2XL, so you can see 2 has been substituted over here, and then this is the equivalency factor. So in this way we are getting a very small number, that is 1174, and we can neglect this. Then look at 2XL single unit vehicles using the formula again. So you can see 0.45, that is the F sub D, 29.78, that is the growth factor, and look at this, 12,000 multiplied by 0.33, because this is the annual average daily traffic in both directions given the question statement, and it is being multiplied by 0.33 because 2XL single unit vehicles are comprised of 33% of the traffic mix. Then 365, that is again 2 because the 2XL vehicles, and 0.005, that is the load equivalency factor. So the equivalent single axle load in this case is 193698. Same thing is to be done for 3XL single unit, and here you can see the values 0.45, 22.78, and here 12,000 multiplied by 0.17, because 3XL single unit trucks are comprised of 17% of the traffic. 365, and here as you can see 3XLs are present in that particular vehicle, so 3 has been substituted over here, and the load equivalency factor is 0.0196. So in this way we are getting this number 586729, and if you just add all the equivalent single axle load that we have got in the different categories of the vehicles, the sum is coming 781601, and this is the design equivalent single axle load in this particular case. Now look at this problem. Now in this problem we are going to compute accumulated equivalent single axle load for a proposed 2-lane highway using truck factors. The projected vehicle mix for a proposed 2-lane rural interstate highway during its first year of operation is given below. If the first year AADT will be 3000, the annual growth rate is 5%, and the design period is 20 years, determine the accumulated equivalent single axle load using truck factors given in the table. Passenger cars 66%, single unit trucks, and we are having these categories of vehicles: 2XL 4 tire 18%, 2XL 6 tires 8%, 3XL or more 4%. And then come the tractor, semi-trailers and combination: 3XL 3%, 4XL 1%. So if you just add all these, the sum is equal to 100%. Since the axle loads are not given, the truck factor is to be used in this case. So this formula will be used for the different vehicles categories one by one, and ultimately this formula will be used to determine the accumulated equivalent single axle load or the design equivalent single axle load. So we have already discussed this formula and the various parameters which are being used over here. Description about those parameters are given over here. So number of vehicles during first year. To determine the number of vehicles during first year, we will have to use this formula. If you just look at this formula, here this is AADT multiplied by percentage of vehicles divided by 100 into 365 into F sub D. F sub D, that is the design lane factor. In this case obviously it is 50% because there are 2 lanes, so 0.5 will be used And in fact, we have got this one from the table. Now, the most important thing is that AADT multiplied by percentage of vehicles divided by 100. This can be replaced by AADT sub I. So the formula would be AADTI into 365 into F sub D. Then we need the truck factors for the different vehicles and the growth factor. So tabular solution of the example is given. So look at the various columns. The first column, vehicle type. The next column is number of vehicles during first year. Then the truck factor, growth factor for 5% annual growth rate, and then the equivalent single axle load, ESAL sub I. So we are having these categories: single unit trucks, tractor, semi-trailer, and combinations. And we are not going to consider the passengers vehicles purposely, because the passengers vehicles are not considered here because their effect is negligible. Now look at these vehicles, and the number of vehicles are given in the question statement. Now from this column onward, we are having the solution of the problem. Truck factor we can get from the table, 0.003 for this particular type of vehicle, 0.21 for this, and so on. And then the growth factor for 5% annual growth rate, that is 33.06. Either you can use the formula for the growth factor or you may consult the table. So we have got the growth factor, that is 33.06. Now it's time to use the formula that I showed on the previous slide. So equivalent single axle load can be determined. So in fact, what we are doing, we are just multiplying this with the truck factor, and the solution, or you can say the answer, will be multiplied by the growth factor. So in this way, in fact, we have used the formula for the equivalent single axle load, which is given on the previous slide. So in this way, we have got these values. So if you just add all these numbers, the sum is coming this one, 1204398. So this is the accumulated equivalent single axle load, or the design equivalent single axle load. So in this particular example, you have seen that passengers vehicles have not considered because their effect is negligible. So we can neglect the passenger cars when you are going to carry out such analysis. Here you can see the formula of the growth factor. So you can use this formula to determine the growth factor, or you can consult the table in this regard. Thank you.